in h2 state we shall write the logic case h burst, and if h burst is 3 tick binary 000, then if h select is equal to 1, then begin next underscore state will be equal to s1, and else next underscore state will be equal to idle. So if head select is equal to 1, then next state will be equal to s1, and if next underscore state is equal to, if head select is equal to 0, then next underscore state will be equal to idle. And ending this, begin and end. So this is a case of h burst which is equal to 000, and if in the case of h burst equal to 001, which is incrementing burst of undefined length, so which is equal to 3 tick binary 001, and if here in case of this next underscore state will be equal to s1 only, and if here next underscore state will be equal to h2, and if incrementing, if h burst is equal to 3 tick binary 010, then next underscore state will be equal to s2. Here 3 tick binary 010 is for 4-bit wrapping burst, and in case of 4-bit incrementing burst, that is, sorry, for in case of 4-bit wrapping burst also, we'll begin this case. So if it is 3 tick binary 010, then next underscore state will be equal to s2, and if it is 4-bit incrementing burst, that is 3 tick binary 011, then begin this, and here we should end this. Begin next underscore state will be equal to s2, ending this, and if it is 8-bit wrapping burst, that is 3 tick binary 100, then begin next underscore state will be equal to s2 and ending this, and if it is 8-bit incrementing burst, then it is equal to 3 tick binary 101, and begin next underscore state will be equal to s2 and ending this, and if it is 16-bit incrementing burst, 16-bit wrapping burst, 3 tick binary 110, then begin next underscore state will be equal to s2 and if it is 3 tick binary 111, that is 16-bit incrementing. So begin next underscore state will be equal to s2 and the default statement, begin if h select is equal to 1, begin next underscore state will be equal to idle, sorry, next underscore state will be equal to S1, and else begin next underscore state will be equal to idle. Ending this, and let's write the logic for S3 case also. So begin case h burst. So basically what I'm doing here is, in this state machine logic, previous videos we have already discussed about this state machine logic. This is the ideal case, whereas in this case of ideal case we are making all the flags equal to 0, and if head select is equal to 1 we are going to S1 state, and if head select is equal to 0 then we are staying in the ideal case. So this is the ideal case scenario, and in case of S1 state we are considering the case of H burst signal. So we have already discussed this part, and according to the H burst we are selecting the flag which we want to make it equal to 1. So here in case of S1 state we are making it, and this is a default case, and from going to S1 to further states we are writing the logic here. If H right signal is equal to 1 then we are going, and if H ready is equal and H ready is also equal to 1, if H right is equal to 1 and H ready is equal to 1 then we are going to S2 state, and if H right is equal to 0, and if H right is equal to 0 and H ready is equal to 1, that is a read operation. So if H right is equal to 1 and H ready is equal to 1, this is a write operation. This is a write operation. And if H right is equal to 0 and H ready is equal to 1, this is a read operation. So basically, if in case of write operation we are going to S2 state, and in case of read operation we are going to S3 state. So this is the coming to else, the default state is S1, and coming to S2 state we are again considering the H burst signal, and if H burst is equal to 0 0 0 we are considering the H select. If it is equal to 1 then next state is equal to S1 else idle, and we are considering H burst which is equal to 0 0 1, then it should be in S2 state only, and if it is 0 1 0 it should be in S2 state only, followed by another scenarios we are writing here. So now let's write the logic for S3 state. This in this states we are considering the case of H burst signal only. So in S3 state begin case H burst, let's consider the single transfer burst. If it is equal to 3 tick binary 0 0 0 then begin, yeah, if it is 0 0 0 then it is an single transfer burst. So beginning this, and if H select is equal to 1 tick binary 1 then begin next underscore state will be equal to S1, ending this, and if H select is equal to 0 then begin next underscore non of if else begin next underscore state will be equal to idle, and ending this case also. And similarly if 3 tick binary is 0 0 1, here I will copy this and paste it over here and replace all H2s with S3. That's it. Yeah. So in case of S3 state, we are considering the case of H burst. If it is 0 0 0 and if H select is equal to 1 then next state is equal to S1, and else next state is equal to idle, and if it is 0 0 1 next state is equal to S3, and if it is 0 1 0 next state is equal to S3, so on. And we are ending this, and We'll write the default for the entire case. Default begin next underscore state is equal to idle, and ending this and end case and end. We will write another logic for making our outputs, that is for modifying our outputs. Always at the rate posage of h clock begin if not of h reset end, then begin h ready out will be equal to 0 and h response will also be equal to 0 and hr data will be equal to 0 and write address will be equal to write address only and read address will be equal to read address only, and ending this else. So basically if there is a reset, if reset is equal to 0, then h ready out, h response, hr data, write address and read address, we are giving their values. H ready out will be equal to 0, response will be equal to 0, hr data will be 0, and write address will be write address and read address will also be equal to read address. Else if h reset is equal to 1, then we will write the logic. Else begin, we'll take the case of next underscore state. Here we are considering the case of next underscore state. If next underscore state is equal to idle, then begin h ready out will be equal to 0 and h response will also be equal to 0 and hr data will be equal to hr data and write address will be equal to write address and read address will be equal to read address, and ending this. And if next underscore state is equal to s1, then begin h ready out will be equal to 0 and h response will be equal to 0 and hr data will be equal to hr data and write address will be equal to h addr and read address will be equal to h addr, and ending this. So basically in S1 case we are making h ready out equal to 0 and h response is equal to 0 and hr data will be equal to hr data, but write address will be equal to h addr, which is h addr is the input for our module, and read address will also be equal to h addr, which is the input for our module. So here what I am doing is, we have already written the next state logic. So in case of next state logic, in case of S1, if next underscore state is equal to S1, here we can see if next underscore state is equal to S1, then we will consider the case of H burst. And if next underscore state is equal to S1, then we are writing the logic parallelly here. Our H ready out should be equal to 0, H response should be equal to 0, and HR data will be HR data, and write address equal to H address, and read address is equal to H address. H address is the input address for our module, and we have already written the logic that in case of S1, we are considering the case of H burst, and according to the H burst, we are making the respective flag equal to 1. So this is what we have done so far. So in case of S1, when next underscore state is equal to S1, the signals will be equal, we are assigning the values to the signals, and according to the H burst, we are making the respective flag equal to 1. So this is what we have done so far.